Assalamu alaikum, everyone. Today we are going to start May-June 2023, paper 2-2. Okay. Question number 1. Choose from the following oxides to answer the questions. Each oxide may be used once, more than once, or not at all. Okay. So state which oxide is neutral. If you recall the neutral, there are two oxides which are considered to be neutral: carbon monoxide, nitrogen oxide, N2O. So if we see over here, they have given carbon monoxide, so it is your answer. Now, part B, H2O is an amphoteric oxide, and here H2O is not given, Ahmad Mushtaba. Reacts with a calcium oxide to form slag in the blast furnace. So if you recall, calcium oxide is a basic oxide. So with this, an acidic oxide is going to react. And the acidic oxide which reacts with calcium oxide in a blast furnace, we have this equation that calcium oxide reacts silicon dioxide, SiO2, to form CaSiO3, calcium silicate. Answer is SiO2, which is over here. No, H2O, see, H2O is not the answer because carbon monoxide is a neutral oxide and slag is the impurity, Oliver, which is formed during the extraction of a metal. Okay. We cannot consider water as a neutral oxide. Keep in mind, although water has a pH which is equivalent to neutral, but water reacts with acid and base both. And neutral oxides are the one which does not react with the acid nor react with the bases. So that's why carbon monoxide is the answer, because these two are the neutral oxides. Water is considered as an amphoteric oxide, and slag is basically, this thing is called slag, this compound. And it is formed as an impurity. It is formed to remove the impurity from the blast furnace, from the iron. Is this clear to all of you? Okay. Now, C part reacts with warm dilute hydrochloric acid to give a blue colored solution. Okay. So, if you recall, the colored compounds are formed by transition elements. And here, this is the transition. And if you recall, when copper is in its aqueous state, it forms a blue solution, right? So it means that the answer of C part would be copper oxide, CuO. C. Now D part is amphoteric. So if you recall, Al2O3, ZnO, lead oxide, and H2O. All these are considered as amphoteric. So here if you see ZnO, so we are going to write this as our option for a answer for a D. So it's zinc oxide. Very good, Ahmed Mushtaba. Contains an ion with the oxidation number of +3. Okay, normally in aluminium oxide and iron 3 oxide Fe2O3, in both of them, aluminium has a +3 oxidation number and iron has a +3 oxidation number. So this would be the answer over here for part E, Fe2O3. Yes, very good, Kamar. Decolorizes acidified potassium magnate, that is the color, just for the color of the gas, for the gas, and it's a sulfur dioxide. So uh, here sulfur dioxide is given. So this is the answer for part F, sulfur dioxide. So you guys need to remember this. Is this clear to all of you? Okay, Hamza, if according to MS it's H2O, but sometimes there is a error in MS. If you and it's, I think, if let me check if it's at the end of the class, if we got a examiner report for this one. Okay, let me check if we have. 1 minute. It's last year paper, right? And it's May June 23. Right. Okay. No, we don't have over here. Okay, I'll check and share it in the. Okay, here we go. So it's paper 2-3, May June 2-2, right? Air 23. It's 2-1. Okay, they are saying many candidates choose H2O, but CO was also quite popular. So see, both are, they are considering both over here. But if we talk about a pure neutral substance, it's a carbon monoxide and dinitrogen oxide, and H2O is, in terms of a pH, it's a neutral, but in terms of a reaction, it is considered as an amphoteric because it reacts with water, it's react with acid and a base both. Just give me a minute, please. Now, is this clear to all of you? Okay. Now, question number 2. Group 7 includes the elements fluorine, chlorine, bromine, and iodine. If you look in group 7, you will find them like this. Fluorine is the at the top, then chlorine, then bromine, and then iodine. Chlorine is room temperature and pressure. State the appearance of iodine at room temperature and pressure. So if you recall the appearance of the iodine in terms of its color, it's a gray black, and in terms of the state, it's solid. So it's a gray black solid. Okay. Now, part B. Chlorine reacts with the aqueous potassium iodide in a displacement reaction. No, purple is its color in its gaseous state. Explain in terms of electrons why chlorine is an oxidizing agent in this reaction. So see, they ask you why it's an oxidizing agent and you have to explain in terms of electrons. So if you see, oxidizing agent is the one which undergo reduction, and the one which undergo reduction in terms of electron, it gains electron, right? So we are going to write that it is an oxidizing agent because it gains electrons. So chlorine is an oxidizing agent as it gains electron. Is this clear? Yes, very good, Muhammad Haider. Now, B part 2. State the oxidation number of iodine in I2. So in I2, it's an element, so its oxidation number is 0. Then B part 3. Describe what is observed during this displacement reaction. Okay. So here is the equation. Yes. So as the group 7 ions are basically colorless. Okay. Group 7 ions are colorless, and in the solution iodine is formed, and iodine's state is aqueous. So it means the in aqueous iodine is brown in color. So the color change would be colorless to brown. So here we are going to write colorless to brown. C. The rate of diffusion of fluorine gas is greater than that of chlorine gas. Okay. Under the same conditions of temperature and pressure, if the temperature and pressure are same, then it means that it has a lesser MR. That's why it diffuses with a greater rate. They have asked you to find the oxidation number of iodine, Moise, in I2. So in I2, if you see, I2 is a element, not a compound. And in element, when it's in the form of element, then the oxidation number of element is in it is always 0. Okay. Now, state what is meant by the term diffusion. So diffusion, we can state it as it is the movement of particles from higher concentration to lower concentration. Yes, very good, Muhammad Haider, and very good, Mustafa. Now, part 2. Explain why the rate of diffusion is fluorine is greater than the that of chlorine under the same conditions. So if you guys look at the periodic table, uh, let me open it over here. So the relative atomic mass of fluorine is 19 and chlorine is 35.5, right? So yes. So fluorine is F2 and its MR would be 19 times 2 makes it 38. And chlorine is Cl2 and its MR is going to be 35.5 times 2, which means 71. So if you see the relative molecular mass of fluorine is smaller or lower than the relative molecular mass of chlorine. Is this clear to all of you? Yes, Heather, as you guys have a paper, this paper 2 on 3rd of May, right? So after that, we will continue paper 4 till the exam, okay? Yeah, you can write lesser MR as well. Clear, is this clear to all of you? Okay. Now part 3. The rate of diffusion of fluorine increases as the temperature increases. Suggest why using the idea about the kinetic particle theory. So it is simple that uh, uh, if the temperature increases, no more collision. They gain more energy, and as a result, they move faster. So particles have more kinetic energy and move faster. Is this clear to all of you? Yes. Okay. Now, question number 3. This question is about preparation of salts. Zinc nitrate is a soluble salt. It is prepared by the reaction of an insoluble carbonate with a dilute acid. So if you see zinc nitrate, its formula is going to be ZnNO3 twice. So the insoluble carbonate must be zinc carbonate and the dilute acid has a nitrate ion, then HNO3. Is this clear? It's a nitric acid. Now the equation for this reaction is shown. Okay. A sample of 4.5 gram of zinc carbonate is added to 50 centimeter cube of 1.30 mole per dm cube nitric acid. Show by calculation that zinc carbonate is in excess. Okay. So As I have told you, for this kind of a question, you always need to convert the moles, turn them into moles. So if I find the moles of zinc carbonate, so it is going to be 4.50 divided by its MR. So the MR would be zinc is 65, nitrogen is 14, and oxygen is 16. So 65, sorry, carbon, it's carbon over here, 12 plus 48. So it is going to be 60 and 60 and 65, 125, right? Can anyone calculate it and tell me the answer, please? It's 0.036 moles, right? Now, moles of nitric acid. So its volume and concentration is given. So we multiply the concentration with its volume, but volume is in centimeter cube. So we have to divide it with the 1000 to convert it into a decimeter cube. Can anyone calculate and tell me the answer? These are going to be 0.065. Okay. So these are the moles of both the substance which are available to us, right? Now we have to figure out, as zinc carbonate is in excess, so we'll make it a subject and we'll figure out that how much moles of zinc carbonate are needed. So from the balanced equation on the top, we are going to take the mole ratio. Over here is, you see 2:1 the mole ratio. There are 2 moles of nitric acid and 1 mole of it's zinc carbonate, right? So the moles of nitric acid is 0.065 and the moles of zinc carbonate needed for this would be X. So calculate the value of X. So if we calculate the value of X, that it is going to be 0.0325 moles, right? Okay, thank you much. So see, these are the moles which are needed. And how much are available? 0.065. So we can write over here that zinc carbonate is in excess as 0.0325 moles are needed, but 0.036 are available. Yeah, required are lesser than available. Very good, Umar. So that's why it's an excess. Once the reaction has finished, the mixture is filtered. State why the mixture is filtered. If you recall, in this kind of a method, we always use the insoluble solvent is in excess. So we have to remove the excess solid zinc carbonate. Okay, now describe how to make pure dry zinc nitrate crystals from the aqueous solution of zinc nitrate. So we have a zinc nitrate in its aqueous state, and we have to obtain zinc nitrate in its solid dry form. So as it's water soluble, so we are going to heat Oliver, that's what we have calculated. From this ratio, we are able to know that this much amount is needed for this much moles of nitric acid. See, we have these much amounts are available to us. And from the ratio, we got to know that for this much moles of nitric acid, we need X moles of zinc carbonate and X moles are these. So these are the moles which are needed. And These are the moles of zinc which are available. So the available moles are actually greater than the needed one. So that's why it becomes excess. Is this clear? Okay, now we heat the solution to crystallization point. Then allow the mixture to pour. Why we are saying mixture? Because when the crystallization point is reached, then crystals are formed. So that's why we are saying using the term mixture. Then we dry the crystals in oven, or you can write filter paper using filter paper. Okay, now B part. Lead chloride is an insoluble salt. It is prepared using a precipitation reaction. Name two aqueous solutions that react together to give a precipitates of lead chloride. So as they have told you that lead chloride is an insoluble salt. So its formula is PbCl2, it's solid. So we need two salts or two compounds. One contains the lead and the other one contains the chloride, which must be soluble. So lead is a positively charged ion. So we need a negative ion with which it forms a compound which is water soluble, and chloride is a negatively charged ion. So we need a positive ion for the chloride. So for a lead, it's easy that all nitrates are water soluble. So we make it with the lead nitrate. And for chloride, all group 1 are water soluble, or instead you can use a hydrochloric acid as well. Yes, very good, Mustafa. So we can write, and they have asked you to write the name. So you will write lead nitrate and hydrochloric acid. Instead of hydrochloric acid, you can write any other solid soluble chloride like sodium chloride, potassium chloride, lithium chloride, calcium chloride, magnesium chloride, copper chloride. All these are water soluble, so you can use any one of them. Okay, now ammonium sulfate is a soluble salt. It is prepared by a reaction of an alkali and an acid. Name the alkali and an acid. So it's an ammonium. So alkali would be very easy for ammonium. Ammonium is always obtained from the aqueous ammonia. So the alkali would be aqueous ammonia. And sulfate, the negative ion always comes from, in the salt comes from an acid. So the acid which contains sulfate is a sulfuric acid. Is this clear to all of you? Yes, because ammonium sulfate is formed, right? Ammonium sulfate, ammonium is NH4 positive and sulfate is SO4 2 negative. So the ammonium sulfate would be ammonium NH4 twice SO4. So it is always prepared from sulfuric acid, and we need the ammonium ion, and ammonium ion is obtained from aqueous ammonia. So you just go through the notes, you will find all the metal oxides, metal hydroxides, Moise, and aqueous ammonia. These three all are alkali or bases. All the bases, all metal oxides, all metal hydroxide, and aqueous ammonia. These three type of compounds are alkali. Okay. Now question number 4. This equation is about compounds that contain magnesium and nitrogen. Okay. The formula for a nitride ion can be written as N3 negative. It's the nucleon number, and it's the atomic number, means number of protons. Complete table 4.1 to show the number of particles in this nitride ion. So as you see, in this protons are 7, but the 3 negative charge helps me that it has a 3 more electrons, because they are 3 negative charge. So it means the electrons would be 7 plus 3, 10 electrons. Yes, very good, Heather. So there are 10 electrons. Now for a neutron, you have to subtract the nucleon number. You have to subtract the atomic number from nucleon number. So 15 minus 7 gives you 8. And number of proton is the atomic number, which is the smaller value written over here, which is 7. Is this clear to all of you? Okay. Now next part, state why the formula of a magnesium ion is Mg2 positive rather than Mg positive or Mg3 positive. So it's basically when the ion are formed, they become stable. And when magnesium, if you see magnesium, its atomic number is 12. If you will, you see in the periodic table, see over here, its atomic number is 12. So it means it has a 12 electron. So which means first shell 2 electrons, second shell 2 electrons, and in third shell 2 electrons. For example, if it will become Mg1 positive, so it means it loses 1 electron, then its electronic configuration is going to be 281. Still, it is unstable, right? And if we'll form Mg3 positive, then it is going to be 27, still unstable, because the second shell has 1 electron lesser than 8 electrons. So, but when it becomes Mg2 positive, its electronic configuration would be 28. Now see, in this case, its outermost shell is completely filled or has a 8 electrons, so this is stable. So that's why it forms Mg2 positive. So we are going to write over here, it is because Mg2 positive has only completely filled valence electron. As I use the term only, it means that Mg2, neither Mg positive nor Mg3 positive has complete valence shell. Is this clear? Yes, Moise. Good. Now, the formula for a nitride ion is N3 negative. Reduce the formula of magnesium nitride. So if you see, magnesium is 2 positive, magnesium ion, and nitride ion is 3 positive negative. So we'll move the values of the charges in the to the subscript of the opposite element. Yes, very good, Heather. So it is going to be Mg3N2. Now, magnesium nitrate is an ionic compound, two physical properties. So it's very easy for an ionic compound that they conduct electricity, and usually they conduct electricity when aqueous. They has a high melting and boiling points, and they are water soluble. So out of these three, you can write any two. High melting and boiling point, and we can write soluble in water. Or instead of these two, we can write conducts electricity in when they are molten or aqueous. Okay, now calculate percentage by mass of nitrogen in magnesium nitrate. So if you look at the formula of magnesium nitrate, it is MgNO3 twice. So in it, there are two nitrogens, right? So to find the percentage of nitrogen, we are going to put the mass of two nitrogen atoms, which is going to be 2 times 14. And Mg is 24. Nitrogen is 14, but 2 nitrogen makes it 28. And there are 6 oxygens. So 64, 80, 96. So there are the 96. Okay. So if you add them, 100, 120, is it 148? Chemical properties are basically the chemical reactions which they undergo, and different compounds have a different type of ionic compounds have a different chemical properties. For example, if the ionic compound is a salt, it just dissociates in water. If the ionic compound is a base, it reacts with an acid. So if the ionic compound is a carbonate, then on heating it decomposes to give you metal oxide and carbon dioxide. So different ionic compounds have a different chemical properties. Okay, Umar? Okay. Can anyone confirm me that did I calculated the MR correct? And then you have to multiply it with the 100. Okay. So if you multiply it with, you are getting 0.189 and 18.9 is a percent. Okay. But see, they are asking you to write in the two significant figures. So we will round it off to 19. If you write it 18.9, you will get 1 mark out of these two. Is this clear? Okay. Now, question number 5. Carbon reacts with the steam to make carbon monoxide and hydrogen. This reaction is a reversible. The forward reaction absorbs thermal energy. It means that the forward reaction is endothermic, and it clearly helps us to identify that the backward reaction is exothermic. An equilibrium mixture is formed when the reversible reaction happens in a closed system. Okay. Explain why the reversible reaction must be in a closed system for an equilibrium mixture to be formed. So if you see that one of the reactant is in the gas state, so if the system is not closed, then any of the reactant may escape, and if the reactant may escape, so we will not able to establish the equilibrium. Is this clear? So the reactant cannot escape from container. Is this clear to all of you? Now predict what happens to the position of equilibrium when the temperature is decreased and the pressure remain constant. So if you recall, when the temperature is decreased, equilibrium shifts towards the exothermic side. So if you see in the above reaction, the backward reaction is exothermic. So it means that equilibrium shifts to backward or left. And the explanation would be, it is because the backward reaction is exothermic. Very good, Mohammed Haider. Is this clear to all of you? Now, predict what happens to the position of equilibrium when the pressure is decreased and the temperature remains constant. On decreasing the pressure, equilibrium shifts to the side where more moles of gases are present. Okay. So if you see over here, it's a solid and it's a gas. So on the reactant side, we have a 1 mole of a gas, and it's a gas and it's a gas, and we have a 2 moles of a gas. So see, now Heather, you are wrong in this part. So it means that the position of the equilibrium is going to shift towards the right or towards forward. And the reason is that the product side or the right side has a more number of moles of gases. Equilibrium shifts to the right as product side has more moles of gases. No, if there is if there is only one gas on either side, then it can also be applicable. Okay, Heather? It doesn't mean that all the things are gases. For example, if the equilibrium reaction or a reversible reaction is like this, that one reactant is solid and the other reactant is also solid, but they are forming one gas over here along with one solid. So see, in this case, this side is considered to be having a more moles of gas, because here we have a 1 mole of a gas and here we have a 0 mole of a gas. So if we increase the pressure, equilibrium shifts towards the left, because left side has a lesser moles of gas. And if we decrease the pressure, equilibrium shifts towards the right, because the right side has a more moles of a gas. Is this clear? if there is any species which is, no, for a rate of reaction, it cannot be considered over here because there is a no gas over here. For this kind of a reaction, we cannot talk about the rate of reaction by increasing the pressure. But for this reaction, we can talk about the effect of a pressure on a rate, because there is a 1 mole of a gas over here. So we will see that when we increase the 1 mole of a gas, when we increase the pressure, the rate would increase over here. But in this case, the rate will not increase, but it doesn't mean that equilibrium position does not shift. Okay. Now, B part, predict what happens to the rate of a backward reaction when the temperature is decreased. So it's very easy. The temperature's effect is same whether the reaction is backward or a forward. If the temperature is decreased, what happens to the kinetic energy? It gets lower. So the successful collisions gets lower and the rate would decrease. So we are going to write that rate decreases because now particles has less kinetic energy, hence less successful collisions. Now, predict what happens to the rate of a backward reaction when the pressure is increased. So when we increase the pressure, particles come closer to each other. There are more number of particles in a unit volume. So hence the frequency of a collision increases and rate will increase. So prediction is rate increases as now more particles are present in a unit volume, hence greater frequency of collisions or greater frequency of successful collisions. Is this clear to all of you? Yes, if any one of you has any query, please ask. Okay, so we are done with the half of the paper, and the next half we are going to continue tomorrow, and tomorrow we will end this paper. And then on Thursday, we are going to start the new paper. So see you everyone tomorrow. Take care. Goodbye. Allah Hafiz.